Imagine a young boy not much for his school books wandering through the English countryside. His pockets were not filled with marbles or coins, but with beetles, strange rocks, birds' eggs. This was the world of the young Charles Darwin, born in Shrewsbury, England, in 1809. He was driven by an insatiable curiosity, a profound need to understand the why behind everything. He spent hours meticulously observing the smallest creatures, noting subtle differences in form and behavior. Not just a boyish hobby, this was the stirring of a mind that would reframe how we see life on Earth. He loved the intricate, overlooked details of nature. His family home, the mount-sprawling gardens surrounding woodlands, became his first laboratory. He was free to explore, to collect, to wonder. As Charles grew into a young man, the pressure to find a respectable profession mounted. His father, Dr. Robert Darwin, seeing his son's dismal performance in classical studies, decided medicine was the answer. And so, at the tender age of 16, Charles was sent to the University of Edinburgh, one of the finest medical schools in Europe. He was to follow in his father's footsteps and grandfather's footsteps. Yet the reality of medical training in the 19th century was a brutal affair. The sight of surgery performed without anaesthetic horrified the sensitive young Darwin. He found the lectures dull and the procedures stomach-turning, and he soon began to neglect his medical studies in favour of more appealing pursuits. Instead of the operating theatre, Darwin found his true calling in the university's scientific societies and natural history museums. He fell in with a group of radical thinkers and naturalists, men who were questioning the established dogmas of the time. He learned the art of taxidermy from a freed slave, John Edmonston, who filled his imagination with vivid tales of the South American rainforests. He joined the Plinian Society, a student club for natural history, where he presented his very first scientific discovery, that the common sea mat, a simple marine invertebrate, had the power of independent movement. These were his real lessons, far from the lecture halls his father was paying for. Disappointed by his son's lack of progress in medicine, Dr. Darwin proposed a new path: the church. A career as a country parson was seen as a respectable and comfortable life, one that would allow ample time for a gentleman to pursue his hobbies, such as natural history. The offer was the opportunity of a lifetime, but it was not easily seized. Darwin's father was vehemently opposed to the idea. He called it a wild scheme that was disreputable to his character as a clergyman. Dejected, Charles was ready to decline. However, his uncle, Josiah Wedgwood II, intervened. He saw the voyage as a defining experience for the young man. With his uncle's support, Dr. Darwin finally and reluctantly gave his consent. And so, on December 27, 1831, the 22-year-old Charles Darwin set sail from Plymouth aboard HMS Beagle. The ship was a small, cramped 90-foot brig. For nearly 5 years, this tiny vessel would be his home, his laboratory, and his window to the world. The voyage's primary mission was to chart the coastline of South America, but for Darwin it was a grand expedition into the unknown. He suffered terribly from seasickness, yet his intellectual excitement and unyielding curiosity overcame his physical misery. He spent his days on deck when he could, collecting marine life in fine nets, or below deck in his tiny cabin, dissecting his finds, studying them under his microscope, and meticulously recording every observation in his journals. The captain of the Beagle, Robert Fitzroy, was a brilliant but deeply religious and temperamental man. He had hoped for a gentleman companion to share his table and his intellectual life. As the Beagle made its way down the coast of South America, Darwin spent long periods ashore, often making arduous journeys on horseback deep into the continent's interior. It was here, in the dusty pampas of Argentina, that he made some of his most startling early discoveries. Digging into the riverbanks and cliffs, he unearthed the fossilized bones of gigantic extinct mammals. He found the remains of enormous ground sloths, the megatherium, giant armadillo-like creatures called glyptodon. These were not the bones of creatures from some alien world. They were uncannily similar, yet vastly larger than the living sloths and armadillos he saw in the very same landscape. This was a profound revelation for the young naturalist. Why would extinct creatures and living creatures, so clearly related in form, be found in the same geographical area? The conventional explanation was that these were animals that had perished in Noah's flood, but that didn't explain the striking resemblance to modern South American animals. It was as if one form of life had been replaced by a similar but different form. This geographical and temporal succession of species was a puzzle that lodged itself deep in Darwin's mind. He began to wonder about the relationship between the extinct and the living, a question that pointed towards a process of descent and change. His geological observations further fueled his revolutionary thinking. He carried with him the first volume of Charles Lyell's Principles of Geology, a book that argued the Earth's features were shaped by slow, continuous processes over vast eons. In September 1835, HMS Beagle arrived at a desolate volcanic archipelago straddling the equator about 600 miles off the coast of South America, the Galapagos Islands. To Darwin, they at first seemed, well, a bleak and uninviting place, a world of black volcanic rock spiny cacti and strange, prehistoric-looking creatures. He noted the giant tortoises and the marine iguanas, which he famously described as imps of darkness. But it was the seemingly insignificant small birds of these islands that would, provide him with one of the most crucial clues for his developing theory. He collected many specimens, noting their general similarity, but, at first, paying little attention to their subtle differences. It wasn't until he was organizing his collections with the help of the vice-governor of the islands that a startling fact was pointed out to him. The tortoises, it was said, differed from island to island. Apparently, an experienced local could tell which island a tortoise came from simply by the shape of its shell. Darwin began to notice a similar pattern in other creatures, particularly the mockingbirds. He realized that the mockingbirds he had collected from 3 different islands were not just varieties. Island 1, Mockingbird 1, Island 2, Mockingbird 2, Island 3, Mockingbird 3, each distinct species, each unique to its own island home. Why, he wondered, would each tiny island be home to its own particular creation? The most famous example, though he didn't fully appreciate its significance until he returned to England, was a group of small, drab birds that we now call Darwin's finches. He had collected them from various islands, assuming they were all just different types of finches. It was only when he presented his specimens to the expert ornithologist John Gould in London that the true picture emerged. So, Darwin returned to England in October of 1836, a changed man. He was no longer just an amateur naturalist, a seasoned scientist, respected for the vast collections he had sent back during his voyage, celebrated in the scientific circles of London. He threw himself into sorting, cataloguing, distributing specimens to experts for identification. He began publishing his Journal of Researches, which would later become the famous book, The Voyage of the Beagle, a thrilling travelogue that made him a well-known author. But behind all this public work, a secret and much more profound intellectual journey was taking place in his private notebooks. In July of 1837, he opened a new notebook. On one of its pages, he drew a simple branching diagram. At the bottom he wrote, I think, this was his first sketch of an evolutionary tree. Not as a linear chain or a series of separate creations, but as a branching bush, with all species connected by common ancestry. It was a dangerous idea, one that flew in the face of religious doctrine and the established scientific consensus. He knew the controversy it would cause, and for now, he kept his thoughts to himself. He began a process of methodical, painstaking research, a long argument to support his theory. He read voraciously in every field of science. He corresponded with breeders of pigeons, cattle, dogs, learning about the power of artificial selection. He saw how breeders could create dramatic new varieties in just a few generations. If humans could achieve such change in a short time, what couldn't nature achieve over millions of years? This provided him with a powerful analogy. Nature, he reasoned, must have a similar process of selection, but one that was not guided by human desire. So, what then was the mechanism? The key came to him in 1838 while reading an essay on the principle of population by the economist Thomas Malthus. Malthus argued that human populations tend to grow faster than their food supply, leading to a constant struggle for existence. Darwin realized that this principle applied to all of nature. He called this mechanism natural selection. He had found the engine of evolution. Having formulated his theory of evolution by natural selection, Darwin did not rush to publish it. He was a deeply cautious and methodical man, acutely aware of the social and religious upheaval his ideas would cause. He knew he needed an overwhelming body of evidence to support such a revolutionary claim. For 2 decades, he continued his quiet work at his country home, Downhouse in Kent. He amassed a mountain of data from a staggering range of fields: paleontology, geology, botany, animal husbandry. He spent 8 long years conducting a world-class study on barnacles, becoming the world's leading expert, an exercise that really solidified his credentials as a careful, systematic biologist. His life at Downhouse was one of routine and relentless study, punctuated by chronic illness that may have stemmed from his voyage. He wrote thousands of letters to naturalists across the globe, gathering facts and observations. He conducted experiments in his garden, studying the dispersal of seeds and the behavior of earthworms. In 1844, he wrote a 230-page sketch of his theory, a detailed outline of his argument. He gave her instructions to have it published in the event of his sudden death, a testament to how important he believed his work to be, but also how hesitant he was to face the inevitable storm of public reaction. Emma Darwin was a deeply religious woman. The long period of quiet gestation was shattered in June of 1858. Darwin received a letter from a young naturalist named Alfred Russel Wallace. Enclosed with the letter was a manuscript in which Wallace, completely independently, had outlined a theory of evolution by natural selection that was nearly identical to Darwin's own. Darwin was thunderstruck. He wrote to his friend Charles Lyell, "I never saw a more striking coincidence. All my originality, whatever it may amount to, will be smashed." His 20 years of painstaking work seemed to have been for nothing. He was on the verge of being scooped. Faced with Wallace's manuscript, Darwin's friend Charles Lyell and the botanist Joseph Hooker devised a compromise. They arranged for a joint presentation to be read at the Linnean Society of London on July 1st, 1858. This event secured joint credit for the discovery, Darwin's work, Wallace's work, to be read at the Linnean Society of London on July 1st, 1858. It spurred Darwin into action. He began frantically writing an abstract of his ideas. That abstract grew into a full-sized book. The book was an immediate sensation. The entire first print run of 1,250 copies sold out on the first day. It was written in accessible language intended not just for scientists, but for the general reading public, and it sparked one of the greatest intellectual debates of the 19th century. The central idea that all life was descended from a common ancestor, and that the primary mechanism of change was natural selection, were profoundly challenging. It contradicted the long-held belief in the fixity of species and the biblical account of creation, and it seemed to remove humanity from its privileged position as the pinnacle of a divine plan. The reaction was swift and polarized. Many in the scientific community rallied, particularly the younger generation like Thomas Henry Huxley. Huxley became known as Darwin's bulldog. The most famous confrontation occurred in 1860 at the British Association in Oxford. The Bishop of Oxford, Samuel Wilberforce, mockingly asked Huxley whether it was through his grandfather or his grandmother that he claimed his descent from a monkey. Huxley's legendary retort that he'd rather be descended from an ape than from a man who used his gifts to obscure the truth symbolized the clash between the new science and the old religious authority. Darwin himself, a quiet and reclusive man, largely avoided the public fray, letting his book and his supporters argue for him. He continued his work, publishing further books that expanded on his theory, most notably The Descent of Man in 1871, in which he explicitly applied his theory to human evolution. Charles Darwin died on April 19, 1882, at his home in Down. In a remarkable testament to his stature, he was granted the honour of a state funeral. He was buried in Westminster Abbey, just a few feet from Sir Isaac Newton. The quiet country naturalist, once a disappointment to his father, was now recognised as one of the most influential figures in human history. His passing did not end the debate over his ideas, but began their integration into modern thought. His work provided a unifying theory for all of biology, explaining life's diversity in a single elegant framework. The impact stretched beyond biology: medicine, agriculture, psychology, computer science. Doctors use evolutionary principles to understand the antibiotic resistance of bacteria and the virulence of viruses. Farmers use artificial selection to improve crops and to improve livestock. Psychologists explore the evolutionary roots of human behavior. And computer scientists use genetic algorithms based on variation and selection to solve complex problems. Darwin gave us a new lens to view the natural world and ourselves. Of course, his ideas have been refined and expanded over the last century and a half. The discovery of genetics by Gregor Mendel, work that was contemporary to Darwin's but unknown to him, provided the missing mechanism for heredity and variation. The mid-20th century synthesis fused selection with genetics into the modern evolutionary synthesis. The discovery of DNA and the ability to sequence genomes provided breathtakingly direct evidence for the common ancestry of all life, confirming Darwin's branching tree in ways he could never have imagined.